I'm Andrew Butler, and this is a Grasshopper tutorial. It's actually a series, so we're going to be doing this series once a week for who knows, and it might end up spawning some other tutorials. We'll see what happens, but Tuesdays seem to be it. And in the room we've got Arthur, Peter, Colette, and Isabel, and we're going to start learning Grasshopper. So today's probably going to be only about 40 minutes, but hopefully we can try and aim for an hour each week. And so just this tutorial assumes some basic level of knowledge about Rhino and Grasshopper, so it doesn't necessarily explain what Grasshopper is, but it's more so getting into it. So if you've got Rhino 5 does not come with Grasshopper. You have to go download it. You can get that from grasshopper3d.com. Otherwise, if you've got Rhino 6, it should be installed. It comes with Rhino 6. And to be somewhat aware, there's a little button in the top bar of Rhino 6 now. It's a little green one, and that launches Grasshopper. Or otherwise, you can type Grasshopper into the command line, and that will open it up. So what we're looking at right now is the default view. You can see I've got some previous files that I've been working on loaded into this little 3x3 grid. But the main aspects of our Grasshopper script, and I'll get rid of that information, is our ribbon and the canvas is where we write our scripts. So something very important I need to explain to everyone learning Grasshopper is that everything that you can possibly, every component that you can possibly know in Grasshopper is already there. It's presented there in front of you. There are these tabs in the ribbon that effectively take you to all the various different functions, and we'll get into what those functions are in a moment, but they're all there. Mine is going to look a little bit crowded because I've installed plugins. So you can see here I've got Tree8, WB, Honeybee, Wobbegong, Heteroptera, Ladybug. Those are all plugins that I've gone and installed, and they're useful, but we're not going to be covering any of those to begin with because they usually get into very advanced concepts or teach people to ignore concepts. So we won't get into them, but just so that you're aware, that's why they're up there. Another few settings that I like to have for beginners is generally having view and set obscure components to on. What that does, by default, if you have obscure components off, then Grasshopper will create like a compacted ribbon, and turning obscure components on basically tries to show as many of the functions and components as possible depending on how wide your window is. So you're guaranteed to be able to see everything with that setting on. Another thing, and this is really down to taste, I prefer viewing Grasshopper with icons in the components. So for example, this little guy here. Some people prefer viewing it like this, with text representing the component instead. By default, Grasshopper shows text, but I find I'm quite a visual person, and if you're a visual person as well, it's much faster to actually, once you get used to Grasshopper, recognizing components by their icons. So, like Arthur, are you intending to use text or icons?
Can I see the previous one?
Sure. So this is text, and this is icons.
Text and icons. I think text would be.
You prefer
better.
text.
I think so.
So this is going to be a problem, right? Because if you're watching my screen, it's hard to actually know what this component is because it's not saying. It's just like a little symbol. So I have a plugin that helps me teach. It's not something that I use when I actually do my work, but it's called Bifocals, and what it does is it just places these little speech bubbles above the components to tell you what they are. Okay, so this is plain normal. I can get used. I know what that symbol does, but plain normal is now being displayed. So just so you're aware, I'm using bifocals. Please let me know if I'm not using it, because sometimes I forget. But generally, students find this quite useful. Another thing, I'm just going to set my Grasshopper to look default. Just running through why my Grasshopper looks different to yours. I generally turn compass off. So there's a compass in the bottom left-hand corner. And you can see as I move my canvas around, that compass is effectively showing us where components are. I don't see any use to that little widget whatsoever. So under display, I turn compass off. And in the past, it has actually slowed my scripts down, actually working with them. So it's useful turning that one off. And then I also turn on Profiler. And that's then going to give you these little, under each component, a little time. And so if you're ever trying to speed up or work out where your script is running really slow, that'll tell you how long it's taking to run. So by default, this guy takes 23 milliseconds. And so some of my scripts might take 10 minutes, and I can find out where that's happening, turn that off, then do my work. And so every time I make a change, I'm not waiting 10 minutes. Cool? Okay, so Grasshopper is a visual coding language. It works from left to right, and it works in a linear function. So if I were to try and take a plane and move that plane, and then take the moved plane and then move it again by connecting it back into itself, Grasshopper won't allow that. So it doesn't, by default, allow looping. Everything has to happen from left to right. Okay? So the components will actually break if you try and create a loop. And Grasshopper will give you this little warning symbol in the top right. It tells me, recursive data stream found, the component depends on itself. Okay? So it's aware that it's broken, and it'll give you those warnings. So to read a Grasshopper script, you're going to be seeing warnings, and those warnings will look like... Let's go grab a component that definitely will give me a warning very quickly. Those warnings will be highlighting your components in orange. This little speech bubble here that tells us what the warning is, and we'll get into those down the line. You saw that red one before, which means it's broken. So orange means empty, generally. Red means broken. And then I'll say this is white. Means it's working. Green means it's selected. And grey, like everything grayed out, means off. And
that's a dark grey, right?
Dark grey with the icon coloured means on but not visible. Okay? And all of those coloured systems, if you want to reference that, you can find under preferences in palette. And so that'll explain disabled, error, hidden, standard, and warning. Okay? So you can always go back and find out what those colors mean by going to edit preferences. Cool? Now, getting information from into the canvas. I prefer moving around the ribbon purely because it's how I learnt Grasshopper. So if I want to work with curves, I'll go to the curved tab, and all the information relating to curves will be in the ribbon. But if you know specifically the name of the component that you want to use, you can also double click into Grasshopper, the canvas, and type it. So I've got extend curve there. If I type extend curve again, Grasshopper will do fuzzy search and give you all the options available. And so there's extend curve. Cool? Okay. So, and I'll explain a little bit more about that double click system when we get into variables, because there's a few little shortcuts that we can use to work. So now that we've got a fairly good basic understanding of the canvas components, we'll just write a simple script. Very, very simple, purely because we've got half an hour, and it will help us introduce a few types of geometries. So Grasshopper is actually using Rhino's CAD operations. So it has to run off Rhino. And what that means is that we can actually push and pull data into Rhino from Grasshopper. But if I make a point, and so this particular guy here constructs a point from XYZ values, that point, we can see that is being displayed in Rhino, but I like to explain it as kind of like a dreamscape. So think of everything in Rhino as reality. It's fixed, it's solid, it's very hard to change. And think of everything in Grasshopper as a dream. In the dream, we can make really drastic changes, warp things and twist them and play around with them and be very free. But that stuff in that dreamscape isn't physical, and so there has to be a process of getting it from Rhino to Grasshopper and back. So I can't select that point, and if I draw a point in Rhino, that point doesn't exist in Grasshopper unless I tell it to. So the first few things that people have to learn in Grasshopper is actually how to get things from Rhino in. And so in the params tab under geometry and primitives, we have what we like to call parameters. And in here, this displays all the different types of geometry that Grasshopper can actually work with. So if I'm going to ask you some questions, purely because I want to prove how intuitive this is. So think of it as a conversation. If I was looking under the geometry tab and I wanted to bring a point into Grasshopper, which geometry parameter do you think I should be grabbing? Point, right. So point is effectively going to be the thing that does that. And to go and get information from Rhino into Grasshopper, we need to right-click those parameters, and we have the choice of selecting one point or selecting multiple. So let's just use 1 point to pick that first point. That now allows us to actually move our point in Rhino, and you can see the little red cross that represents the point in Grasshopper is now moving relative to that point. So as I move it, it responds. So we can now, that's creating that link from reality to the dreamscape. Cool? Okay, so what we'll do, and now I know a lot of advanced people are going to probably gawk at this, so please don't. We're going to actually we're going to draw 4 points in Rhino. So I've got 2 here and another 2. And we're going to create 4 point parameters. And we're going to use those point parameters, right-clicking each one and selecting 1 point for each to bring each of those 4 points into 4 separate parameters.
So do you just copy the point parameter?
Yeah, you can copy it, and then you can
Control-C, Control-V?
Yep, so shortcuts for Grasshopper are Control-C, Control-V. Every function in Grasshopper that has a shortcut is something you can get via the menu bars in the top, and they will tell you if there's a shortcut. So you can see there copy is Control-C and paste is Control-V. We'll get into a little bit some fun copying tips and tricks maybe in another lesson, because once you know them, you can code faster. Cool. Okay, so Grasshopper runs on functions, and the name that usually gets associated with them is component. So I'm going to use that name from now on. So a component effectively contains a function. A function can be anything from take two variables and add them together. So if I were to say 5 and 3, the result of that, if we put that into the function I just described, would be 8, right? Or another function could be find a point along a line. So everything that Grasshopper runs on is a function. It takes inputs or variables, effectively, and it has an output, and that could have more than one output. So if I were to then say, okay, let's look at the process of how someone draws a line, we normally take that process for granted. So if I gave Pete a pen and he were to go sit on paper and draw a line, he'd draw that line. Subconsciously, he's actually making the decision of where he wants to start the line and where he wants to end the line, right? With Grasshopper, you have to be incredibly specific. The computer has no idea how to make those intuitive decisions, and so we have to be very specific with that. So there are multiple ways of drawing lines in a computer. So if we've got 2 points, by default we can draw a line between them, and in Grasshopper, if we go to curve, under primitive, the very first primitive is line. That line takes 2 variables and has 1 output. And without really knowing what these things do, like I've just got experience with this particular component. If you mouse over each of the letters that describe the variables, it will describe what those variables need to be. So it'll give you a symbol of the type of geometry or parameter it needs. So in this case, A requires a point geometry, and it even gives us a description, line start point, and B obviously is going to be another point. It's going to be the end point, line start end. The output is going to be a line. Okay, every component follows these rules. So if I go grab some of the more complicated ones, like for example the octree component, very complicated component in terms of like actually what it does, but it tells us it wants points as a list, it wants square leaves, and that is a Boolean function, and we'll get into the different types of parameters later. It wants a group, the permitted content per leaf. So in effect, if you have a component that you think you might need to use, and I haven't taught you about it, there are ways of learning about it without actually needing someone to help, because the documentation for it is built into the component. And I think this is one of the most important things to teach, because I still don't necessarily remember every single component in Grasshopper. And the only way that I go and grab it and use it quite intuitively is because the documentation is written into it, and I can learn on the fly what that component does. Cool? So the line component, if we plug our first 2 points into that, draws a line. And if we move the points in Rhino, the line will then respond. Cool. Copying and pasting that, you'll note that components remember their inputs when you copy and paste them. So if we want to replace a wire in Grasshopper, you just drag the component that you want to connect onto it, and it should bully the other one away. So we now have 2 lines responding to those 2 points, those 4 points. Cool. Okay, so we've drawn points, we've got lines. The line parameter is this. This guy here. Also, lines also belong to curves. So lines are both curves and lines. Arcs, splines, any effectively like 2D type of curve geometry is that we know of as 2D is a curve, but we can be a bit more specific in terms of lines. And we'll get in some functions specifically want lines and some want curves, so we have to be careful with that. But in this case, we've got lines. Okay.
Can I ask just quickly?
Sure.
What you were saying about if you sort of hover over the node, that it sort of tells you what it wants.
Yep.
Will it always be just that specific node that it will be able to connect onto, or are there multiple that it doesn't sort of display up, or will it always be just that?
Sorry, what? Sorry.
So say with this one, how I'm hovering over and it's asking for boxes.
No, it's outputting boxes.
Oh, right, outputting boxes.
So the right is outputting and the left is inputting.
So say in here is points.
Yep.
That's the only node that it can take.
If you put lines in, if you put boxes in, if you put a number in, it won't work. Okay. Yeah?
Yeah.
Grasshopper does have some nice user-friendly functions to it. So for example, if a component wants a string or text, so let's say I write my name, Andrew, in, and it runs. If I type a number and put that in, what it will do is recognize that number could be actually converted to text and then convert that to text. So it does those types of functions for you automatically. But if I put a curve in as text, it doesn't know how to convert curves to text. So it can't do that. So there's some limitations to that user friendliness. But we'll move on. Okay. So the lifeblood of most Grasshopper scripts are variables, and you'll see number sliders. These little guys here under input. Number sliders are generally some of the most commonly used ways of putting number values in, and the very utilitarian panel. So panel and number sliders. Let's put a component in to actually use these. So what we're going to do is we're going to create a Cartesian graph curve, like what I used to do back in 3rd grade when I was bored and you had graph paper. It's effectively drawing lines from one line to the other. So what that's going to require is us to divide. So under curve, divide. Oh, here we go. Here's another thing. So if I grab divide curve and I hold Control Alt and then click on the component, it shows you where it is in the ribbon. So you see those little red arrows? So see in the ribbon the division thing? So if you hold Control Alt and click, it'll show you where it is. So I can do that on any component and it will change the ribbon to show you where that is. So we want division, or divide curve, sorry. Divide curve takes 3 parameters. The first parameter being the curve.
It doesn't work for me. Control Alt
and then hold on to the click and hold.
Yeah, and hold. Yeah.
Yep. Very useful if you're intending on teaching this stuff. So if we just plug it in by default, if we mouse over N, it tells us that it's already by default putting 10 value. It's dividing by 10 that line, and it's by default false if we want to split segments at kinks. We don't necessarily need to worry about the segments. We're just going to play around with the number of divisions. So if we divide our curve by just a default slider, default sliders go from 0 to 1, then all we're going to get is either nothing at all or 1 division. Okay, so we want to be able to divide this by more than 1, or otherwise we're only going to get 2 points at the start and the end. So our number sliders can be edited by double clicking on the name of the slider. That'll bring up a dialog that then gives us options. We can name it, not necessarily the most important thing. We can give it an expression, maybe something I'll go into later. But the most important things are the types of rounding, the number of digits, the minimum, maximum, and range. Okay, so rounding, R is effectively a floating point number, so that's a number with decimal points. N is a natural number, so integers, so numbers that are whole, that describe, for example, the number of things in a set. So how many people are in this room? There are 5. We can't have half a person. There can only ever be like whole numbers of people. And then the last 2 are even and odd whole numbers. So we can, for example, control our slider to only ever give us 2, 4, 6, 8, or 3, 5, 7, 9. Okay, so in this case, when we divide something, we can't technically divide by a floating number. We have to divide by natural numbers. So let's select n. We can't divide by 0, or otherwise, if the computer allowed it, it would just stop. So we want to set the minimum to 1, and let's set the maximum to something crazy like 100. Okay.
Crazy, huh?
You'll see why. Don't go too crazy. And so now that I've got that slider set up, that gives me the control to effectively divide by 1 up to 100. Cool. Okay, so really important thing. I could actually copy both the divide curve and the slider down and plug our other line in to then divide that bottom curve. And so now both these curves are being divided by 2 separate sliders. Really important thing to know is a variable, such as a slider, can be used by more than one component. So if I plug my slider in to the other divide curve, now, and deleting our second slider, we can now divide both curves at the same time.
Couldn't you just put that line in the top part of dividing?
Oh, you mean do this?
Yeah.
Okay, so this is where I'm saying this is getting a bit. So there's beginner and then there's advanced.
Okay.
So yes, you can actually do a function to multiple items. We will get onto that very soon. Okay, but no, it's good because actually I want to encourage people to think intelligently about not only how they produce their geometry, but also how they code that production. So copying and pasting is generally a really annoying thing. So if I have a script that could do, let's say, makes one building, and then I need to copy and paste it to make a second building and a third building, wouldn't it be better to write the script so that you don't have to do anything other than just slip the slider from 1 to 5 to get 1 building or 5 buildings? But we'll get into that. But I'm glad you brought that up because it's quite important. Either way, you can share these variables. So, for example, this point here could actually be the point that we draw for that second line. So just so that you understand that. Sorry, this is getting dry, Pete. Okay, so this is quite important though. Every function that we've done, every component that we've used, we can look at using a panel. So if I drag a component into a panel, it'll tell me what the output is. So this is telling me I've got a referenced point. Then if I drag the line in, it tells me the line, and because lines are really nice geometries, it also tells me how long it is. But then if I pull up the divide curve, the critical thing here is there's more than one item. And this is really getting into the power of Grasshopper. This is a list. And once we start working with lists, we can start doing multiple things at once with Grasshopper. So to begin with, we're going to work with a list that has the same number of items. So in this case, we've got 1 point in this list and 1 point in this list. And so the outcome is we get 1 line. But if we've got a list of, in this case, 18 items and another list of 18 items, when we run a function on that, we're going to end up with 18. So first thing is, how do we look at a list? They are generally going to be in order. They're always going to be in order. They always start at index 0, and that is a computer science thing. So one's actually not a very nice number to start with. It's actually 0. And I'll get into that in another lesson as to the power of that. And it goes up. So if we look at 17, we don't actually have 17 items because the 0th item is the first one actually. So there's 18 items. So Grasshopper, if we run another function, so we've got points in a line. If we draw points from one list to another, what it will do, and yes, it's done what I want. What it will do is draw the first point, a line in this case, from the first point to the first point of the second. The second point to the second, third point, third point. Okay? We'll get into slightly more complicated data structures maybe in the next few lessons. But the most important thing here is the order. So in my first list, which happens to be this line here, I drew this point first and this point second, which means in my division, the first point at the top, the first point's going to be at the top, second point, third point, fourth point, all the way down to the last point at the bottom. I drew my second line from left to right, which means my first point's on the left and my last point's on the right. I know I'm saying very obvious things, but it becomes important because this Cartesian graph curve wouldn't look like that if I changed the order of any of these lines. So if I were to draw them like so, it ends up looking like a suspension bridge diagram instead of a Cartesian curve. Okay, so the first item will always draw to the first item. Order matters. Cool. Cool. Okay, so we've actually got something that used to take me like half an hour to draw by hand in, let's say, half an hour. It took me to teach you guys, right? But now we can actually make any type of graph. We can change the number of the divisions on that graph using the slider, and we can change our curves that define it. Also, at any point in this system, we can make alterations. So we could, instead of using a line, we could use an arc, and we'll get into that. So, let's just actually make this wrong. Let's say you actually have something like this, and we need to fix it up. There are two ways to go about it. So we could manually go in and flip the curve. That's annoying. Or we can make sure that data follows that function. So curves go from start to finish. There are functions that let us edit curves, such as flip. So flip curve, if we run our line through flip curve, we get our Cartesian graph. Or another sneaky one is reverse. So under list, and these give us list functions that we can work with, there's reverse list. If we run our points that are in a list through reverse list and plug that into the line, it will also give us that same result. Okay, so there are many ways to skin cats in Grasshopper. We can deal with that through list manipulation, or we can deal through it with geometry manipulation. Either way, it's giving us the same result. Sorry if this is a little bit boring for beginners. Okay.
And you can reverse the points.
Pardon? Yeah, so we've reversed the points here. And if I reverse these points, then
You
we'd
can
get...
take at the line.
Pardon?
At the line.
Ah, yes, that's also a really good suggestion. You could do this. You could flip those, and that will also produce the same result. So there's yet another way to skin that cat. What was I going to point out? Okay, but function like reverse is very utilitarian. It comes up a lot depending on your coding. So Grasshopper's given us a way to actually reverse lists and do other list functions in the components themselves instead of putting in a new component. So you can right-click an input or output. So I'm just going to set this back. So if we right-click P on the divide curve, you'll see there are these little shortcuts that you can add. And some of them I'll explain later, but there's reverse in the top. So if you right-click B or P, we can then reverse that list, and we don't need the reverse list component. Cool. And that last thing, panels. So we've used a panel as a way to look at data, but panels can also be a way to type data in. So you can grab a panel and type a number. So let's say I'll type 10 into a panel. We can then instead use that panel as the variable instead of a slider. Okay, now, nice little trick. If I normally drag these in, that will replace them. Yeah, but if you've got a set of wires that are connected to a node and you want to move them from one component to another, shortcut, you can hold Control-Shift. That'll give you the ability to pick up all those wires and then drag them into another component. So Control-Shift, and you can pull it up. A lot of people don't know that one for some reason. Cool, so that's using a panel. And now a nice little trick for sliders and panels to finish off in the next 4 minutes is perfect. With the double click function for typing, we can actually get panels and sliders by typing in certain things. So / will automatically give you a panel. So if I hit enter with 2 forward slashes, it will give us a panel. If I type / and then anything, like let's say my name, it'll give me a panel with my name in it. So that'll help coding. And then for number sliders, there's a nice little syntax that you can do. So if you type a number in, let's say 50, it'll give you a number slider that goes from 0 to whatever the next unit of 10, or sorry, not unit, power of 10 is. So 50, the highest 10 power above that is 100. So that'll be 50 to 100. If I type 2, the highest one above that is 10, so it'll go from 0 to 10. Now, if you want a little bit more control over that, you can type the minimum number that you want. So if, let's say we go from 5 to 9, 5 is less than 9. And that will give you a slider going between 5 and 9. And last but not least, you'll note that all of these have ended up being integers. If you want it to be a floating number, then you just need to make sure that one of the numbers that you type has the number of decimals that you're looking for. 5 is less than 9, and that will give you that decimal accuracy that you're looking for. Cool.
Thank you.
Has everyone learnt at least one thing?
Yes.
Other shortcuts. One we're going to get into later involves adding more than one wire to a variable, so you can have more than one component, and that's what Colette was sort of alluding to. Another one, if you hold Alt and click and drag, it will actually stretch your whole model, like it'll move everything to the right of that model out, or if you drag left, everything left. I rarely use that shortcut. And then the final shortcut is the middle click button, which what that does is it gives you a selection of different elements. So for example, if I want to turn off this component, I can click it, middle click, and that turns off. Now you can see we're starting to get, this is erroring because it's empty. If I turn that back on, yes, last thing, Grasshopper shows you every step of the process, okay? So if I use construction lines to set something out, you can see those construction lines at any point. If you don't want to see them, you have to hide the component that's calculating them. So if we select every component that we don't want to see, we can middle click, use this little dude with the blindfold, and that will then hide it. Okay, so if you don't want to see something, you can use that. I've seen some people in the office, they're getting a bit, they're using this button up here, only draw preview geometry for selected objects. With that on, it will show nothing unless you actually select the geometry component, like the actual component. It will then preview it. I find that infuriating because I like to see multiple things at a time. I don't want to go through and constantly select things, but feel free to use Grasshopper however you wish. Cool. So that is the end of 101. Very, very, very beginner. Thanks for putting up with the super basics. Huh?
Thanks for teaching.
That's okay.
How do you, if you wanna, sorry,
No problem.
how do you disconnect that one?
Disconnecting wires. That's a
Yeah.
really good point. There is a shortcut that I've seen and I've forgotten it. I prefer to right-click either the input or the output, and then select disconnect. That'll give you the option of which wire you want to do. If you've got multiple wires going in, there will be an option for disconnect all.
You can hold control.
Control and
Is
leave
it-
it back to the original.
You sure about that?
You have to plug it
Pull it
back
out and
into
then
the
press
old one.
control.
If you do this, yeah, so you can create that connection, but you should see some of my scripts that
They're like,
it's mental. You're better off just going to either the source or the input and picking from there. So yeah, you can drag that wire in whilst holding control. I think if you hold Control Shift, there was a way of doing that. No. Also, Rhino 6 has this new component called, if you double click a wire, they're called relays. They basically, they're set up to help you organize the script. They do nothing other than let you move the wires around. If you make a relay and then delete it, it doesn't actually delete the wire. So some people were hoping that that you could double click a wire, then delete the relay, and then it would be disconnected. It doesn't work. But that is another way. That's a way to organize.
So it's a bit kind of slow to kind of try and disconnect them. Is that
the best? Generally, once you start getting into codes that have like 5 to 10 to 20 things going all into the one input, it's much faster just using the right click method. So that's what I prefer. Also, the right click method tells you exactly which, like it shows you the cable that you're going to be removing. It tells you the name of it. If you name a component, so for example, if I name point the first point, in the right-click menu, it will show up as the first point. So even though I've got super messy scripts, they're set up in a way that I can navigate through them my way. And so you're more than welcome to come up with those things. Panels I find are really good for writing notes. So note, a lot of people like using this guy here called Scribble. You double click it and you can type stuff in, but the text in Scribbles isn't searchable. So generally I prefer to put components in like a data component. Right click that, you can set a name. So we could say graph section. Then click this little icon here, and that will then display the name of that. What that means is later, let's say I'm somewhere else in the script, I can use this find function and look for graph section, and you can see here there's a component called graph section. If I click that, it'll actually take me to that component, whilst Scribbles don't allow that. So it's up to you how you use that. Most people like Scribbles. I'm a bit weird. Cool.